Hello class, in this lecture I will be talking about hypothesis testing for two population means. Using tstat. So when I say two population means, we are comparing two different populations. And tstat, as you might know, we use tstat when n is less than 30. This is when we discussed previously in one sample hypothesis testing, the tstat can be used when n is less than 30 and sigma is unknown. I will try to explain the concept again. We have a population. So this is population, and then maybe this is population 1 and it is city 1. The weight, we are comparing the weight. So the weight of population 1 or city 1 is represented by mu1, and then we have population 2. So this is population 2, that is our city 2, and then the weight, average weight of this city 2 is given by mu2. And then we previously discussed in hypothesis testing, when we define our hypothesis, three situations can happen. One is mu1 is equal to mu2, that means the weight of city 1 is equal to the weight of city 2. So this can also be written as mu1 minus mu2 is equal to 0. When we subtract two different numbers and we get 0, that means the two numbers are equal. So this is a two-tailed test, because we are saying city 1 weight is equal to city 2 weight. So we can kind of disprove this hypothesis if city 1's weight is less or city 1's weight is more than city 2. So we can kind of evaluate on both sides of a normal distribution curve. So the other situation that can happen is mu1 is greater than or equal to mu2. So that is mu1 minus mu2 is greater than or equal to 0. So this is one tail, because we are evaluating only one side of our normal distribution curve. So that means we are saying city 1 one's weight is more than city 2. So this is the first, second, and the third situation that can occur is mu1 less than or equal to mu2. That means city 1's weight is less than city 2, and again this is a one tail problem, because we are evaluating one side of a normal distribution curve. So this can be written as mu1 minus mu2 less than or equal to 0. So our hypothesis, three different situations can occur. So the first situation is our null hypothesis, mu1 minus mu2 is equal to 0. That is the first situation. And our alternative is mu1 minus mu2 not equal to 0. Or this can also be written, so it depends on how your Hawk's learning asks you to key in these values. Mu1 is equal to mu2, alternative will be mu1 not equal to mu2. So both are same. So the second situation will be H alternative. mu1 greater than or equal to mu2, or you can kind of say h null mu1 minus mu2 greater than or equal to 0, and our alternative will be h alternative mu1 less than mu2, or h alternative would be mu1 minus mu2 less than 0. So the third situation that can occur is, so this is a two-tail problem, this is a one-tail problem, and then h null is equal to mu1 less than or equal to mu2, or you can say h null mu1 minus mu2 less than or equal to 0, and alternative will be mu1 greater than mu2, or you can say alternative is mu1 minus mu2 greater than or equal to 0. So this is again a one-tail problem. So once we have this, what we do is, once we have an hypothesis, we go and we try to prove our hypothesis. So we take a sample. So to prove, we collect data. So we take a sample from this one, and the sample size is n1, and you get the sample mean to be x1 bar and the sample standard deviation to be s1. And in this also you will kind of take a sample n2 of size n2, x2 bar would be the sample mean, and s2 would be the sample standard deviation. Now to use t, we discussed n is less than 30, so in this case n1 should be less than so let me go here, n1 should be less than 30, and then in this case n2 should be less than 30, and then since s1 and s2 are given, you won't have sigma 1 and sigma 2, so that means sigma 1 is unknown and sigma 2 is unknown. So in that case, if these two cases are fulfilled, you will be using tstat. So I will again try to, so the step 2 is to compare, step 2 of a hypothesis testing is to compare test statistic with critical value. So here again we are saying test statistic, we will be using t stat, and then we will be using t stat. Our formula would be for t stat x1 bar minus x2 bar minus mu1 minus mu2 over square root of sp square. So this is sp square 1 over n1 plus 1 over n2. So this sp square here is pooled variance or common variance. So this sp square, the formula would be n1 minus 1 s1 square plus n2 minus 1 s2 square divided by n1 plus n2 minus 2. So that is our formula for pooled variance. So tstat, again, when do you use tstat? In this, n1 less than 30, n2 less than 30, less than 30, sigma 1 and sigma 2 are unknown. So again, in this, one of the assumptions, couple of assumptions we make is sigma 1 square is equal to sigma 2 square, and the population distribution is normal for tstat. So if sp square is pooled variance, sp will be pooled standard deviation or common standard deviation. So that is what the concept is. So this is the concept of tstat as such, which we will be discussing. And now test statistic, once we have that, now we will be comparing it with critical value. So the critical value, you remember previously we said if it is a two-tail problem, then it will be T alpha over 2 degree of freedom, and if it is a one-tail problem, it is T alpha over T alpha with degree of freedom. This is comma, maybe I will rewrite it, T alpha comma degree of freedom. So for one sample, in our previous one sample, when we had one sample, we said this would be n minus 1, and if we have two samples, the degree of freedom would be, for the first one n1 minus 1 plus for the second one n2 minus 1. So the degree of freedom for two samples would be n1 plus n2 minus 2. So that means for this one you are looking for two-tail, T alpha over 2 comma n1 plus n2 minus 2 degree of freedom. For one tail you are looking for T alpha n1 plus n2 minus 2 degree of freedom, and then finally you will make a conclusion. So we will try to solve a problem on this and try to understand this concept. So I took a problem from Hawk's Learning, and it was actually a one-tail problem in Hawk's Learning, but I converted it to a two-tail problem. So let's look at what the problem says. Maybe I will use a different. A manufacturer claims that the calling range in feet of its 900 megahertz cordless telephone is different than of its competitor. So when they say different, it means it's a two-tail problem. A sample of 12 phones from a manufacturer has a mean range of 1150 feet with a standard deviation of 27 feet. A sample of 7 similar phones from its competitor has a mean range of 1100 feet with a standard deviation of 23. Do the results support the manufacturer's claim? Let mu1 be the true mean for the manufacturer's cordless phone. So mu1 is, I will write that manufacturer's, so this is manufacturer's phone, and then mu2 is competitor's phone. So this is very important, how you define mu1 and mu2. So use a significance level of alpha is equal to 0.01 for the test. Assume the population variances are equal and the two populations are normally distributed. So now they said the cordless, the first sentence says a manufacturer claims that calling range of its 900 megahertz of cordless telephone is different than that of its competitor. So they gave us alternative which says mu1 is not equal to mu2. So the other way of writing this as mu1 minus mu2 is not equal to 0, and then null will be mu1 should be equal to mu2. So the alternative, the null hypothesis can also be written as mu1. So you can write one of these. It depends on what Hawks wants you to learn. Hawks learning wants you to type. So this is mu1 minus mu2 is equal to 0. So this is your hypothesis. So now let's see what is given. So this is given, what data is given. So this is manufacturer, and I will write competitors data here. So let's see what data is given. A sample of 12 phones. So n1 is equal to 12 because that's related to from the manufacturer, had a mean of x1 bar is 1150, and then with a standard deviation, that is S1, is 27, and then N2, so a sample of 7 similar phones from its competitors, 7, x2 bar is mean range of 1100, so this is 1100, and the standard deviation S2 is given as 23, and then we have a significance level of 0.01. So this is the question. So the second step, we wrote the first step which was our hypothesis. So the second step of the hypothesis testing is to compare test statistic with critical value. So the test statistic value, now which test to use, if you see here we have, because S1 is given and S2 is given, sigma 1 is unknown, so population standard deviation is one unknown for the manufacturer, and sigma 2 is unknown. They didn't give those to us in the problem. And then n is less than 30 because it's 12, n1 here, and n2 is less than 30. So we are, based on these, we are able to make we are able to use tstat. So since we are able to use t statistic, I will write the tstat formula. So t is equal to x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sp square. So this is s 1 by n1 plus 1 by n2. So this is pooled variance sp square. So sp square, the formula is n1 minus 1 multiplied by s1 square, n2 minus 1 s2 square divided by n1 plus n2 minus 2. So I will just take this and calculate here. N1 is N1 we have 12. 12 minus 1 multiplied by s1 square, that is 27 squared, plus n2 we have 7. So 7 minus 1 s2 squared, that is multiplied by 23 squared, that is and then 12 plus n2 is 7 minus 2. So when you calculate this, you will get sp square of 658.4118. So you will take this and substitute here. So we will do this x1 bar. Again I will take this x1 bar is 1150 minus s, x2 bar is 1100, and then mu1 minus mu2 will come from h null. So mu1 minus mu2 is equal to 0. So this is coming from h null, so this will be 0 divided by square root of sp square. Sp square is 658.4118. 658.4118 multiplied by 1 by n1. n1 is 12. 1 over 12 plus 1 over n2 is 7. So this, if you calculate, you should get 4.09. So this is the t value, test statistic value. So once you have that, you will be doing, the next step is to calculate the critical value. So again, because our problem is mu1 is equal to mu2 or mu1 minus mu2 is equal to 0, this is exactly. So we can disprove this if mu1 is greater than mu2 or mu1 is less than mu2. So we are looking at both sides of a normal distribution curve. So now I will be calculating critical value. So since we know this is a two-tail problem, we will be doing t alpha over 2, and then the degree of freedom for this will be n1 plus n2 minus 2. So our significance level to calculate test statistic alpha is given as 0.01. So alpha is given as 0.01. So alpha over 2 would be 0.005. So if I wanted to show this in a normal distribution curve, so this represents the h null curve. So h null curve is mu1 minus mu2 is equal to 0. So this curve represents this h null, mu1 minus mu2 is equal to 0. And then because it's a two-tail, I have this point and this point. So this I wanted this would be a confidence interval of 0.99 because this is 0.01. So in this region, if you consider this region, our null hypothesis will be true. So that means do not reject H null. So here H null is true. So this part, if you consider, this would be alpha over 2, which is 0.005. Here you will reject H null. So that means alternative would be true. So inherently you are saying alternative is true. So this also reject H null. So again, because this is the negative side, when we reject, this will be mu1 less than mu2, and this will be, because this is a positive side, so this is a negative side and this is a positive side, mu1 will be greater than mu2. So that's how we can reject it. So once we have this, we need to calculate, we know alpha over 2 is 0.05, so we know this is 0.005. So we need this n1 plus n2 minus 2. So n1 will be 12. So if you see, n1 is 12, n2 is 7 minus 2. So this will be 12 plus 7 minus 2, that is 17. So we are looking for t 0.005 alpha over 2 and 17 in a t table. So t table usually gives this value because it gives you right side of the curve. So this would be t 0.005 and 17 value would be this point, and this would be negative t 0.005 and 17. So let's go to our t table and look for what are those values. So I will go to our canvas page and then do modules and then go to calculation aids and then statistical tables. I will download it and then I will open the statistical tables spreadsheet. I will do enable editing and then currently I am in Poisson table. I need to go to t table and then I am looking for t 0.005 and 17. I will go to t table and look for t 0.005. t 0.005 is this one, and then degree of freedom 17 is this, so I go and look for this value, that is 2.8982. So this value is 2.8982. okay, I will rewrite it, 2.8982. this will be negative, so this point 2.8982. so that is this point and this will be this point, so that is this one. So now we go to our test statistic value. So the test statistic value is 4.09, and we see where does 4.09 lie in this curve. So in a number line we have 2.8982 here, so 4.09 would be somewhere here, so this would be 4.09, so that means it falls under reject H null. So we are doing reject H null. So what does this mean? We are saying that mu1 is equal to mu2. This is a false statement, so that means the competitor is not the manufacturers and competitors are different. The range is different, the calling range. So if you want to consider which one is better, you are saying you fall on this, the right side, mu1 is greater than mu2. That means manufacturers is better. Manufacturers calling range is better than competitors. So this again we can use confidence interval to look at this. So the formula for confidence interval for mu1 minus mu2 is would be x1 bar minus x2 bar minus plus T alpha over 2 n1 plus n2 minus 2 degree of freedom multiplied by sp square 1 by n1 plus 1 by n2. So in this expression, let me highlight. So this is critical value, this is standard error, and then this sp square is pooled variance, that we have discussed earlier, and this whole expression, this whole thing is margin of error. So again this we will solve by using calculation aids, but if the lower limit and the upper limit are negative and positive, that means mu1 will be equal to mu2. So if both are negative, that means mu1 will be less than mu2, and if both are positive, mu1 will be greater than mu2. So that's how you'll solve confidence interval, and we kind of proved manufacturers is better than competitors in this. So we will try to solve both hypothesis testing and confidence interval by using calculation aids. So let's look at this problem by using calculation aids. So again I will copy down all these from here. The hypothesis I will include, to everything given I will include, and try to solve this problem. So the first thing is the hypothesis is mu1 is equal to mu2, or your null hypothesis mu1 minus mu2 equal to 0, and then alternative would be mu1 minus mu2 not equal to 0. Your this or you can say alternative would be mu1 minus mu2 not equal to 0, and the data given, I will note down this data. So this is given in the problem, again this is coming from the problem itself, so all these data I'm copying it. So given so this is manufacturer, and then this is competitor. So the data is N1 is equal to 12, x1 bar is equal to 1150, S1 is equal to 27, and N2 7, x2 bar is 1100, and S2 is 23, and alpha is 0.01. So let's go and download our calculation aids and try to solve this problem. So I will go to our canvas page and then go to modules, go to calculation aids, and then do chapter 11 calculation aids, download it and open this one. So which sheet you will be using? You will be using, so we have 4 sheets: known variance, unknown variance, mean, paired, and proportion. Known variance is mostly used with Z if your sigma 1 and sigma 2 are known. Currently, if you see this problem, let me go here. In this we have S1 and S2 given. So sigma 1 is unknown, sigma 2 is unknown, so we will be using unknown variance sheet. So I will copy down these numbers. So I will go to unknown variance sheet, and then the gray area is what I have to fill in. So the first cell, which is sample mean for sample 1. So let's see sample mean for sample 1. So the sample mean for sample 1 is 1150. I will type in 1150 here. And then sample standard deviation. I will go and look what is that. Sample standard deviation. So the sample standard deviation is 27. So I'm going to type in 27, and then the sample size. Sample size is 12. So the sample size is 12. And then for sample 2, we'll go and look for sample 2, what is the sample mean? So the sample mean for sample 2, which is competitor, is 1100. So I will key in 1100 here. And then sample standard deviation. Sample standard deviation is 23. And then finally the sample size. The sample size here for competitor is 7. So this is 7, and I need alpha. Alpha is 0.01. So I will type alpha of 0.01. Hit enter. So if you see, we got pooled variance 658.411, which we calculated, test statistic 4.09, standard error would be 12.20. So currently, which case to use for hypothesis testing? Do we want to use case 1, case 2, or case 3? So they are asking us to look at how does your alternative hypothesis look. So how does this alternative hypothesis look? So I go and look for how does my alternative look. Mu1 minus mu2 not equal to. So I will go here and look for which case has that. So if you see, mu1 minus mu2 not equal to is here. So this is less than, this is greater than. So I will be using case 3. So my critical value is 2.89 and I will reject H null. So again, I have standard error, I have critical value, and then my confidence interval lower bound is 14.63 and upper bound is 85.36. So I will note down those confidence interval. 14.63, let me go, okay. So my confidence interval is 14.63. So this is a positive number. And what is my next one? So 85.36, this is also a positive number. 85.36. So this is 85.36. So this is also a positive number. So that means mu1 is greater than mu2. That means manufacturer's range is better than competitor. So the other way of concluding this is to say, so the conclusion would be there is sufficient evidence so what does the question says? Is different than its competitor. So there is sufficient evidence that the range is different for manufacturer compared to competitor. Because it is greater than or it is better than. So there is sufficient evidence to conclude that manufacturers range differ from competitor. So that is the end of my lecture on hypothesis testing for two populations using tstat, and in this I talked about two-tail. In my next lecture I will be talking about one tail. Thank you.